Okay. So we are live. Hello, everybody. As you come in, we already have a few people coming in from all over. So I'll just wait a few minutes and welcome the audience. So we started a bit early today just to make sure things were working. Today we don't have Yamur. I'll be the one who will be presenting or introducing. So while you're here, maybe it might make sense to please share with us where you're speaking from. So on the right side, you see the chat window. Could you please write down where are you speaking from in the world? I know there are a few people from Germany for sure. We had signups all over the world. I think this was Nuremberg. Okay, quite late for you, just like in Munich. Paris. Oh wow, a lot of Europe coming in. New York. Okay, we did try to optimize for the US. With this time slot, we've never done it so late in Europe before. Of course, Alex and I are based in the EU, but Morocco. Oh wow, what is the time in Morocco? Do you think it's 10 p.m.
or 8?
or 8? Yeah, plus
One or the
minus
other.
one or the other. Yeah, we have a colleague in ZenML in Morocco. So fun. Pakistan. Yeah, that's where I'm from as well. So glad to have some Pakistani representation. Germany. Good. So let's wait a few more minutes as I think now the time just started. Perfect. Hello, Tunisia, Barcelona. That's great. Yes, people coming in. Amazing. Welcome everybody to the second webinar hosted by ZenML. Really looking forward to this one. I know that LLMs and Gen AI is a topic that we've been working on internally, but haven't talked about so much in the public. And today I think is the start of us consistently hopefully creating more useful content and relevant content in the context of ZenML with large language models. So okay, we have Barcelona, Germany. Yeah, I mean, I'd also be interested for those listening. Do you have any applications of RAG in production currently? If you can just write in the chat. Are you running a RAG pipeline or workflow in production with real users? I'd be super curious because whenever I talk to people, they're still mostly in the POC phase. All right. Mubin says yes. That's great. I haven't. I mean, of course, I've seen a few implementations out in the wild, but I think the hallucinations and the evaluation part, which we'll touch on, makes people a bit hesitant. Cool. David says yes as well. Wow. Okay, we have a few practitioners. So for those who are just joining in, yeah, Alex.
I was going to say, I think often the use cases we see with RAG pipelines, like out in the wild, actually deployed, are like internal RAG pipelines quite often.
Exactly.
So where the risk is a lot less.
Exactly. Yeah, it's a bit risky still in production, but people do tend to put them out there. So I think we've waited a few minutes so we can officially start. So welcome officially, everybody. My name is Hamza. I'm the co-founder of ZenML. And of course, today we are going to be talking about building and optimizing RAP pipelines, data processing, embeddings, and evaluation of LLM workflows. I'm joined with my colleague, Alex. Alex, you want to give a brief introduction to the people?
Yeah, hi everyone. Yeah, I'm an ML engineer. I work closely with the open source side team in ZenML. Been working here for 3 years, and I'm based in the Netherlands.
Fantastic. So I just have one more question, and then I'll hand it over to you, Alex, and we can dive right in. I know you're jumping at the bit, but I just close with the last question. What kind of vector store are you using for your data if you're using a RAG system? I'm super curious. What sort of vector store are you using? Are you using Pinecone, using MongoDB? I met a founder today who told me they were using MongoDB. Pinecone, okay, very popular. PG Vector came from Pinecone. Okay, wow, that's a very interesting use case. I think very, very relevant for today. MongoDB. Okay, perfect. Cool. Yeah, that seems to be the ones that are the popular ones. Cool. So I am going to now start. Actually, I think the first part is just introducing the agenda. I'll give a brief introduction and then hand it over to Alex. So for those of you who don't know ZenML, I thought I'd start with a company overview. So we are around 15 people spread all over the world. We've made over 100 releases in the last 3 years since we've been live with our product, with our open source product. And I think we had more than 20,000 pipelines run last month, although I think that doubled since we wrote that slide. We have an open source offering and a managed offering both available, and we are used in production by hundreds of companies all over the world. You can see at the bottom some logos that you might recognize. We have a great and thriving Slack community. So for those of you who are not in the Slack community, please join. You'll get early heads up for these webinars. You'll get a lot of content delivered to you, a lot of practitioners talking about, amongst other things, LLM ops. So I'm very excited. So the problems NML solves, just to maybe give you a broad context, is that ML platforms are notoriously hard to build, and they evolve very quickly because the space changes. You can see, for example, in the world of GenAI, there's a whole new stack forming with vector databases, RAG applications. So it's a continuous movement to try to integrate all the tools, all the infrastructure, all the different personas. And what ZenML helps you to do is it creates an experience layer around that abstracts away a lot of the complexity of the infrastructure and still brings in a central layer of metadata and truth so that you can build your own ML platform, even if you have disparate tooling and infrastructure needs. So that's really the angle at which we look at it. We don't want to replace any tool. So we don't want to replace your orchestration tool. We don't want to replace your experiment tracking tool, but we want to be a place where we can bring things together. The goal is to make MLOps simple and accessible. I guess we can also call it LLM ops now. But I guess at the fundamental layer, it's pretty the same. And we want to bring different personas together: ML engineers, data scientists, data engineers. I'm sure we have a whole bunch of mixture in the audience today. And briefly, how it works for those who haven't used it before, we have a concept called steps and pipelines, which is our Python SDK, very similar to a pipelining tool where you can decorate your Python function with different configuration of infrastructure, write whatever Python code you want in there. And then on the other side, we have a CLI and an interface to create stacks. That's the other important concept. And the stack defines your infrastructure, whether it's Bento ML for deployment, Kubeflow for pipelines, Slack for alerting. Maybe you want to use Great Expectations. Maybe you want to use MongoDB for your vector store. These things would be classically represented in a stack. And then the framework pulls it all together. So rather than you having to string all these things together, our framework would, do things like building an image, running training, deploying models, stuff like that. So that's just a quick rundown of what ZenML does. And I just wanted to briefly touch upon why a look back at large language models in the context of 2024. Of course, a lot has happened in the last 2 years. I don't want to bore the audience. You're probably very plugged into what's happening. But I think just summarizing the top 4 things that were exciting trends this year, we had expanding context windows, which puts the RAG question quite in the forefront. Do we need RAG in the context of expanding context windows? Probably yes. Spoiler, but Yeah, this is a question still evolving. We had many open weight models, open source models. I think that's pretty clearly the winner in a lot of ways. Evaluation and leaderboards. So we have the LMSys chatbot arena, the Gorilla function calling leaderboard, MTEB, which I think was quite recent. People are very excited about sharing their results and evaluations of these models. And I think this is one of the most interesting areas that you can really see and compare how people constantly beat each other, even enterprises. And just a few days ago, we had the Apple conference where they also sort of hammered home one of the trends I think we will see a lot is local on-device models with their Apple Intelligence, so the AI that they brought into the market. Of course, with a player like Apple coming, we know this is going to happen probably across the mobile world, and with like Siri integrated into a local device, which then goes into ChatGPT. These are very. It feels like the very early innings of a very transformative change of technology. Um, I can see some people saying some more trends. So compute efficiency, of course, I think there's another law out there, which is how efficient are we getting by training these models? Every year we somehow decrease the cost by a magnitude. That I expect to continue for the next few years as well. But broadly speaking, one of the most exciting technological trends that I've personally seen in my career. So I, I think it's a very good point that we are looking at how to do this in production. And I feel like every day we talk to more and more people who are doing it actually in the real world. And today I'm going to be, I'm super excited myself, Alex, to listen to you as you talk about how to take a RAG application from a prototype phase and productionalize it slowly using ZenML. So with that, I'll hand it over to you.
Thank you so much, Hamza. We can go on to the next slide, please. So yeah, Hamza was talking about RAG, and I just thought maybe it's worth taking a second to make sure we're all on the same page. Obviously, those of you who already have RAG systems in production will know this, but I just wanted to kind of get back to the basics a little bit. So RAG is Retrieval-Augmented Generation. The term itself comes from a paper that Facebook and Meta wrote in 2020. And basically the concept that we're dealing with here is we have a certain amount of information. Potentially, you want to ask questions about all of your company's documentation or something similar. And you have an LLM, and ideally you'd want to give all of this information, give it to the LLM along with some question, and then get some answer out. LLMs are good at reasoning over large amounts of text and so on. The problem comes with the fact that these LLMs, till now at least, have generally had a limited context window, it's called. So a limited amount of information that it can take in. Until last year, this was really limited. Now with bigger models, as Hamza was saying just now, potentially you have 10 million tokens as your context window, but there is some kind of bottleneck here. So RAG is basically a technique to deal with this problem. So with RAG, we find a way to pick the most important pieces of information from this huge amount of data, your company's data, whatever it is, and we pick the most relevant ones to your query, and that limited set of data are the things that we pass into the LLM as part of the prompt, basically, in order to get the answer to our query. And I thought I'd just jump in. We can go to the next slide if you want. Hamza? Yeah. I thought I'd just kind of, again, go back to take this in a really simple form in code, just so you can see before we start adding on extra layers, the production layers, because it's as this as this tweet shows, there's a lot of jargon, particularly now, particularly in this early stages of working with LLMs, and there are simple concepts behind them, but then a lot of kind of complicated jargon often gets put on top. So I thought I'd just start with code. So Hamza, if you could switch to my ID. Yeah, so we've got a basic RAG pipeline here, and I just thought I'd walk you through it, and we can run this code. So we've got a corpus. This is a sci-fi themed corpus about ZenML world with some made-up animals that we can ask questions about.
Alex,
and yes,
can I bother you for a second? Sorry, could you zoom in a few clicks just so that it's a bit easier?
yes. How's
Thank
that
you.
now?
Yeah, that's great.
Okay.
Thank you.
So we've got this corpus, and it's a bunch of different documents, let's say, different sentences, and we'll follow the kind of the steps that someone would take in a normal RAG pipeline or a RAG process. We would pre-process this text in some way. So if we look at the actual function that's doing the pre-processing, all we're doing is we're turning the words into lowercase, we're stripping out the punctuation and some other things. So a very basic form of pre-processing. And then we have a series of questions. With RAG, you usually have a question that you want to ask about your corpus. And if we look at the function that's doing the getting the answer for the question, the first thing we do is we retrieve relevant chunks. So we have this corpus, and we want to retrieve the top n number of chunks that are relevant to a particular query. Now, in this example, we have a super naive way of retrieving relevant chunks. We're just essentially seeing the overlap or the intersection between the words in the query and the words in the corpus. So if there are lots of similar words, then we can say there's a high similarity. It's much more naive than you would do in a real world use case, but again, this is RAG in 85 lines of code, so we have to simplify things. And then once we've got the relevant chunks, we can just pass this into a very simple prompt that we pass to, in this case, ChatGPT. Based on the provided context, answer the following question. We provide the query, we provide the context, and then we get out the response from the LLM. I can just run this for you, and I will zoom in a bit. Most basic RAG pipeline. And so we see here, like, our questions are being answered. The answer is whatever is coming back from the LLM, synthesized from the relevant pieces of the corpus. And we can go to the next slide in the presentation, Hamza. So what we have here is, and what I just showed you in code, we have a retrieval part, which is the top half, which is basically about both storing the information that we have in a form that is searchable and is retrievable, and then the bottom half, which is about generation, which is synthesizing the most relevant parts. And so RAG is these two parts, and it really helps to think about them, and it helps to think about, like, the evaluation in terms of in terms of separate terms as well. But this is in an overview. The simple example that I just walked you through in code, this is more or less what you're going to be doing in a RAG system yourself. And this is what the kind of the frameworks like LangChain, Llama Index, etc. This is what they're all doing as well under the hood if you look at the code. Next slide, please. And of course, evaluation is an important part of the RAG workflow, or particularly once you get into something that you're deploying to users, because you really want to be able to know whether the answers that your LLM is putting out are actually the real ones. obviously, if you look at some examples yourself, it's pretty easy, particularly if you're familiar with the actual information. You can figure it out, but at scale, you can't just have humans checking things before they go out to users. And also, when you're developing these systems, you want to have ways of checking this. So we can go back to the code now, and I can show you a very basic evaluation as well that we can do. So what we can do is we can have kind of basically handcrafted examples, and we can pose a question, and then we can write the expected answer ourselves, and then we can see whether the LLM actually provides this expected answer. And obviously, this will work for specific cases where there are things that we know it's going to struggle with, maybe that we want to make sure that are covered. That is checking the output, the kind of the generation part, and then the retrieval part. We can say basically, for a particular question, we want certain chunks from our corpus to be part of this. I'll show this later in a more in-depth example. But the evaluation then is essentially just iterating over these particular kind of evaluation data or examples that we provided, checking for the retrieval, that the relevant chunks are being retrieved for a particular question. And for the generation part, we actually use an LLM as a judge here. You are an evaluation judge, given a question, an answer, and a generated answer. Your task is to determine whether the generated answer is relevant and accurate. Respond with yes if it's satisfactory, or no if it's not. Most simple kind of evaluation that you can imagine. And then, well, the rest of the code is just iterating over that. And if I run this, basic eval. So what this is doing is it's just iterating over those examples. You can see the judgment being put out each time from the LLM, and we get a perfect score on both retrieval and generation. You'd hope so, because here actually you can see that the expected answer is more or less identical to the generated answer, with a few words that are different because the LLM has synthesized it in some way. We can go back to the slides, Hamza. So this, if we just kind of take a step back, this is what's going on in RAG evaluation. We have these two kind of intervention points where, in general, we want to check whether things are going right. We have the retrieval, which is checking whether we're getting the right things from our vector store, database, whatever. And then we have the generation evaluation, which is this, you can use the LLM as a judge there. Is this response, is it coming out in the right way? Is it coming out how I'd expect it to come? Are there strange things being output? Can we check for hallucination, this kind of thing? So the kind of question we're asking with evaluation is, how good is this response, and how can we find a way to quantify this somehow? So what I'm going to talk about now, that was kind of the overall big picture. Firstly, I'm going to pause, but what we're going to talk about next is a kind of a more in-depth example, which relates to a kind of a chat QA bot for RAG. Hamza, I was wondering if there are any questions which maybe we want to dive into now.
So there are no questions yet, but I would encourage people, if they have any, to leave them in the chat. I was just going to make a remark that this RAG in 80 lines of code or 60 lines of code, I think we did a few of those and you wrote those up. I personally was very struck by how intrinsically simple it is what we're doing. Because when I first, like a year and a half ago, 2 years ago, when I first coded up the RAG applications, it felt a lot more complicated. And I feel like this was very informative for me personally to understand. I mean, even though you did the most basic things, like post basic stuff, I think it's just very good to understand the fundamentals. because at the end, what you're going to show us, I think, is how you can optimize in each piece, and why, abstracted frameworks like LangChain really did come into the picture, and DSPY and all those things.
Great.
Yeah.
Well, yeah. Drop your questions in the chat if there are any, and Hamza, I'll trust you to raise them when they come up.
Sure.
So here in the screenshot, I mean, you can see an example of the ZenML Slack bot, which is currently actually down, I think, or not up, I should say, intentionally. But yeah, the idea is, as is very common in the world of RAG applications and RAG pipelines, people often build this kind of chat Q&A bot, which is over a bunch of documents, and this can either be internal or external public facing. So what I'm going to talk you through is one which does this for ZenML's documentation, and some of the kind of the ways we implemented this and how we thought about it. Next slide, please. So I'll just talk about the kind of the first bit first. The first thing, obviously, you need to do is get your data sources or get this documentation all in the right place, and then split it up somehow, and then pre-process it. I'm going to take you through the code in just a second. Next slide, please. And then, once you have all of the documents in the right format, and in a way that makes sense, then we generate embeddings for each of these individual chunks that we've split up. And the embeddings are basically a way to allow us to do this search to retrieve the best ones out of this larger corpus. Obviously, there are naive ways, as I showed you a little bit in the RAG in 85 lines of code example. There are naive ways of searching for your information. Even you could just do a kind of a keyword search. But for larger documentation corpuses, obviously you're going to want to have something which performs a bit better, both in terms of speed, but also in terms of like accuracy of finding documents. And if a particular keyword isn't mentioned, we'd still want the right documents to show up. So yeah, we generate the embeddings, and then next slide. Then we store the embeddings in the vector store, and this vector store can be a whole bunch of different things. We heard a little bit from the audience earlier, a whole bunch of different options. In this example, we're using Postgres, but yeah, let's go to code now. Thank you.
Can I maybe, I know we're going to go through the code, but just for somebody who's wondering in production, how does one select a vector store? Like, what are the reasonings you would make to select Mongo versus something like, I don't know, FAISS or something like that?
Sure. That's a complicated question. I mean, basically, it's going to be determined a little bit from your use case. Well, a lot from your use case, I would say. There are kind of very useful tools, which are kind of leaderboards or kind of matrices, whether you can select, whether you want a self-hosted one versus one which is hosted by someone else. It's also going to be a bit determined by the volume of your data, the kind of latency requirements that you have. What else might be included? If you have very small, use case or data sets, maybe you don't even need a vector store. Maybe you just need a NumPy array. I think this is a famous Karpathy tweet, but I just use NumPy as my vector store.
Yeah. No, I mean, like, I heard a few times that, we already had Mongo, so we're just going to use Mongo. We already had Postgres. We're going to use pgvector. We have a few questions here. From M. Saad, how can we utilize multimodal embeddings?
Multimodal embeddings. I mean,
that's multimodal, maybe not multimodal.
Multimodal. I'm not sure. We need to get clarification. multimodal versus multimodal.
It might have been multimodal, actually. That makes probably more sense. So for different modalities, image,
Yeah.
video.
I mean, you would use it more or less in the same way that you use it for text. I mean, in the end, it's still just a search function, right, across your data. And there are going to be some different considerations you have in terms of how quickly you can retrieve the data. And obviously, chunking an image is kind of a weird concept. You probably won't be splitting the images up into sections.
Yeah.
There's just some different considerations that you'd have.
Yeah. There's a couple more. Do we want to take them now, or do you want to keep going?
Maybe let's get a bit further into the code.
I will
first.
ask them at the right time. So hold for a second.
Okay, great.
Mhm.
So what you can see on the screen now is just the kind of very simple ZenML pipeline, which handles basically the first part, the generating the bit in the orange that you saw previously at the top of the screen. So running a ZenML pipeline, as you can see, is pretty easy. You just add a decorator and a pipeline decorator on the top, and then you have your step functions underneath, which are just basically functions. And you pass these in. So we have the URL scraper, which is retrieving. It's just crawling the ZenML docs website to get a list of relevant URLs. We have a web URL loader, which is basically just using the very useful unstructured package to convert, to load the URLs and to convert the text from HTML format into something a bit more closely resembling Markdown or kind of Markdown light. And then at the end of this, we're just kind of packaging them up into a data class called document, where we store the text, the URL, as well as the parent section. The parent section is kind of a piece of metadata about the document. Where does it come from? What's the parent section in the documentation? And again, here, just noting that like a ZenML step, pipelines are composed of steps in ZenML. You just create one by adding this at step on the top. It's all pretty simple syntax. The pre-processing for the documents is also, for this case, relatively simple. We're splitting the documents up by a particular chunk size, and we're choosing whether the chunks should overlap. And all this is doing is just cutting the document up, making sure not to split it in terms of like splitting up specific sentences. And there's kind of an art to choosing the chunk size. Maybe we can get into this later, Hamza, talking about like how you should decide these two things. It'll differ a little bit for use case to use case, and also there may be more pre-processing things that you want to do. And just as a little note, we're also logging these things to ZenML as artifact metadata. In fact, I can show you this in the pipeline. This is in the pre-process documents step. If we just look here, looking for
in the metadata of the split chunks.
Yes. Okay. Oh yeah, here. So you can see we've got the chunk overlap of 50 and a chunk size of 2000, and there are 2071 chunks which are generated when I ran this last time, whereas there were originally 493 pages in our documentation. So you see it's kind of increased it by a factor of 4 approximately.
And then just a quick one, because we had a question. Sergio asked, for data processing, do we need to remove special characters? Just a quick note on that. I just from basic information retrieval, I think it makes sense to remove punctuation and special characters and normalize lowercase the text. I think this is pretty standard in information retrieval and indexing in general, just to normalize the data. Even if you lose some information, you gain a lot in the vector embedding step to make the vectors appear closer when they're semantically similar. So my normal answer would be, I would say that you should remove punctuation and special characters, unless the special characters are in another language. which you need to semantically insert into your corpus.
Right.
Yeah.
If they're essential, then then you
Yeah.
wouldn't want to remove them. But it's really going to depend on the use case, I would say.
Yeah.
But yeah, and also the embeddings that you choose. But let's talk about the embeddings now. Generating the embeddings, we're doing something really pretty vanilla here. We're just using kind of Hugging Face sentence transformers model, the old mini LM L12. If you look in people's code bases, you'll see this really everywhere. It works very fast. It's pretty performant. It's a good like starting point to choose for embedding your documents, and then all we're doing is basically encoding the specific text and then adding it into the to the document as a document as an embedding property. Nothing really special there. And then in terms of kind of passing this the embeddings and documents and so on into our vector store or into our database, as is our case, we just have basically some SQL queries we connect to Supabase. We create a table if it doesn't exist, and then we're just inserting each of our embeddings into Supabase. Of course, only doing this if it doesn't exist, and I can just show you this in Supabase what this looks like. Yeah, we've got some content. These are the chunks which we're passing in. Each chunk has a particular embedding, so this is its kind of location within the vector space. Then we have this kind of metadata concept, whether it's in the how-to section or the stack components, and then the URL as well as the token count. So yeah, this is where it lives in Postgres.
Alex, are Superbus using the latest PG vector stuff? You know, the one that came out today with 75% speed increase?
Yes, so that's PG vector scale. So I guess that would you would only probably want to use this if you had had those scale requirements. For our case, it really doesn't make sense. But you know, Supabase is just hosting Postgres, so yeah, you can use it.
Yeah.
I'm pretty sure.
I think that's a good link to the question Thomas had with what are the size limitations, the max token size you have experienced with your RAG model while being able to maintain a high retrieval standard?
Size limitations for the RAG model. So is
I mean,
this the
our use
size
case with
limitations of the chunks?
yeah, I think that's what Thomas meant. Maybe you can clarify, but I feel like our use case with the Slackbot was quite simple, so we could get away with quite good retrieval standard with
Yeah, we never hit the limit of
small
what
chunk
we had to
size. Yeah.
pass into GPT or these models. Maybe if
Yeah.
you were really trying to stuff it with context, then you would hit those limits, but
Mhm.
we never really hit those limits.
Yeah, I heard a few people had retrieval latency problems with PG vector at scale when it if you had to retrieve a lot at the same time. But I think that also can be tuned with the normal database optimizations that you do with Postgres anyway.
Yeah, and that would be the reason why, you know, I'm sure someone might ask, you know, why are you using Postgres? Why aren't you using these fancy vector databases, Pinecone or whatever? And I mean, Postgres is like a really a known quantity. We know how to optimize. We know how to optimize kind of queries at scale for Postgres, and with the other databases, certainly we don't know as well. And it's just like less predictable for different loads. So yeah, and it's also, you know, your team, your teams may be more comfortable with one versus the other.
Yeah, makes sense.
So that basically is the kind of the full set of pieces that make up the. We can go to the next slide. These are the pieces that make up the kind of the beginning of the of our RAG pipeline, getting everything ready. And then we have the inference part, which I can, which we've talked a little bit about the model, but sorry, I'm just getting my terminal ready. Yeah, you're on the right place. So for inference, really we're just passing our query in, and then it's retrieving things from the vector database in order to synthesize the question. So I can just run a query here, for example. How do I use config with my ZenML steps? This is a kind of a common query, which sometimes you hear in Slack, people asking this. And it's using GPT-4 as its default model, so which is why it's taking a little bit of time.
Is it, Alex, if I may just, so that pipeline you showed before, which did the upper part of the flow, that you presumably ran before, and you indexed
Yes.
all the documents, and that was what we were showing in the ZenML cloud or the
Yes.
ZenML Pro interface, right? So
Yes.
so you already indexed the data, and now you're just querying and asking Postgres and then GPT-4.
Yes, exactly. And I can show you the code, but there isn't really much to it. It's essentially more or less the same as the kind of the quick example. We say, here is a little bit of context. Here is my query. Come up with an answer, please. And it spits it out as Markdown, so I can just use Rich to format it nicely. You can see, you know, I know from having run this before that the answer is correct, and it's a useful answer, I would say. And of course, we can play around with this. We can use a smaller model or kind of a less capable model. It'll run quicker, but we probably will get less text coming back, and you get a little bit more. Yeah, so you get fewer examples, the kind of a less fine-grained approach. So this is, and I can show you even one example where it doesn't do so well. So this is Claude Haiku, which again is a pretty fast model to run from Anthropic with the same question. And this starts kind of basically putting out gibberish, not complete gibberish, but it starts giving a list of all of the environment variables. And, you know, this is just, I guess, kind of a caution that, like, you can have the same prompts and things, but they don't work interoperably between different kind of model families. And this is where a little bit where evaluations, which I'll come to in a second, come into play. There is one, if we can just go to the next slide, there is one extra piece to RAG, which is worth mentioning, because, you know, when we're doing the inference at the end, you know, we can think about how we can improve this. How can we make the inference part work better? And the answer to that is re-ranking, which is basically, as you can see in the diagram, instead of just taking the top 5 chunks, or the ones with the highest similarity score from the vector store, we get the top 20, so a far wider pool, and then we use a separate model called a re-ranker to order these in order of relevance to the particular query. And then we take the top 5 of those and give those to the LLMs to synthesize together with the query. And it's a relatively simple idea, but as I'll show you in a second, it does quite well. And it's quite useful. Let's go to the next slide, please. So we talked a little about evaluation. I just want to kind of talk about this in the context of our pipeline itself, because in our simple example, you know, we had some relatively simple questions that we wanted to guard against, but for a production use case, there are a whole bunch of things that could go wrong and that we want to guard against. So let's take a look. Next slide. Yeah. So remember when I was telling you there were 2 parts, there's retrieval and generation, and retrieval is kind of the one we want to look at first. And that's making sure that we're actually getting the right pieces from right documents that are relevant to a particular query. So you can see in this, we have a handcrafted data set, and we're just checking, did we retrieve the right documents? So let's go back to the code, and I can show you an example of what I mean by this. So here are just kind of a bunch of pairs of questions and URLs that I've crafted myself. And you will know your data best, and you'll know what are obviously kind of correct answers. So for example, in the case of ZenML, if someone asked, how do I get going with the Label Studio integration? What are the first steps? Knowing ZenML and knowing our documentation, I would really expect that our single page about Label Studio annotator, this would have to be part of the data that was retrieved from the vector store. At least there would need to be one chunk, at the very least, that would need to be part of that top 5. And then we can come up with some other examples of things that we know where there's just one page where this thing would answer this question perfectly. And there are a bunch of other kind of ways of testing these same things, but this is kind of a simple one. And as you come across failure scenarios, you can add to this list. And but you might say, how does this work? This doesn't cover all of the possible use cases, and that's where you might want to think about synthetic data. So we can go back to the next slide. And this is basically, we want to find a way to generate these pairs of question plus particular URL at scale across our entire data set. So we can just go back to the code, and I can show you a little bit what that would look like. We basically want to iterate over all of the chunks we have and pass them to a language model with a very simple prompt. This is some text from ZenML's documentation. Please generate a question that can be asked about this text. So we give it a chunk, and then we ask for a question. And with that, you can go over your entire data set and generate some data. So here, for example, we have a public data set, which is available on the Hugging Face Hub. So you can check it out. We have all of our different chunks. This is similar to what you saw in Superbase a few seconds ago. And we have a chunk of text, and we can see that we've generated a question about this. This chunk is all about visualizing artifacts in the ZenML dashboard. And the generated question was, how can I configure ZenML to display data visualizations for the data board, and so on. And actually, in the code, this was all done with a local model, a Llama Mixtral, on my local computer, because this stuff can get, if you're doing this at scale across all of your data, can get pretty expensive quickly. So you might want to certainly start off experimenting with a local model, a cheaper local model. But obviously you can also use Claude Haiku and GPT 3.5. They're more than good enough to handle this. And we can go to the next slide, Hamza. And I'll show you exactly how this stuff kind of turns out in the end when you run it through a pipeline in ZenML in a second. But I just want to talk about the other side of this, the generation evaluation now, where basically, again, we have a handcrafted test set, and we're wanting to check certain properties in it, whether it is well, it's probably easiest if I just show you, so we can return to the code. If I go up to the top, so you can be kind of creative in how you do these evaluations that you write for yourself. So, for example, for our example, there are certain questions that I know that, for example, what orchestrators does ZenML support? I know that there are certain words that I never want to show up in the answer because they're just not true. I know that ZenML does not support a flight orchestrator or prefect or Dagster orchestrator. So that would really be like a wrong answer if this ever happened. Similarly with other questions. So we can basically ask this question together with the vector store and the database and stuff that we loaded in previous steps. And if we ever see any of these words in what gets responded, then we can give a low score. And some of these words actually I added here because I saw in experimenting that it was performing badly. Or these words were showing up, so I want to kind of guard against them. And if we go to the next slide, There is one final kind of evaluation, which is quite popular, which is the idea of having kind of an LLM as a judge. And this is kind of an automated way of evaluating the responses that come back. And we can go back to the code. I can show you the kinds of things that that come out. For example, here I'm interested in the kind of the toxicity, the relevance, the helpfulness. We can pass these kind of criteria into an LLM. Actually, we're passing this into GPT-4, and we say, please analyze the following text and the context, and check whether the response that the LLM gave, whether it is helpful, faithful, how toxic is it, and so on. And you can do this across many different examples and across your data set to get a sense of the kind of aggregate scores. I can show you an example of what this looks like in the kind of evaluation pipeline right now. Yeah, these are all of the different kind of evaluation checks that we did, but I can just show you the a graph showing how some of these scores turned out for our particular model. So yeah, here we have a score of 1.0 for toxicity. So that's from on a score rating of 1.5. That's a perfect score. And then we have still some room for improvement on the helpfulness. And these are across a bunch of different evaluation questions. And here I just wanted to show you the retrieval scores, because here you can see actually the impact of re-ranking on our retrieval tests. So on remember that Hugging Face data set that I showed you, when we ran the evaluation without re-rankers, we got a 1.8 failure rate. So 1 is good, 5 is bad. And then with re-ranking, you see we have a distinct kind of improvement there, which is improving that retrieval score.
And just to maybe, I think we should talk a bit more about how these visualizations are generated. So you ran all of the code that you showed us, you put in a ZenML pipeline, and you're sort of running these pipelines as you're doing your experimentation and storing the visualizations in, I believe, Azure or GCP or something.
Yes, we're using an Azure artifact store here.
Mm-hmm.
So the images which are being output, we have a step which is just visualizing the evaluation results, and it returns an image object, which then ZenML picks up and is able to output as a visualization within ZenML.
Cool. So I think that's a good link to Mubin's question. When your documentation is updated, how do you make sure that your vectors are also up to date? Would this be real time? How do you make sure that you don't, get one index updated with another, or don't duplicate the contexts?
Well, I mean, that would be in the logic of how exactly you're populating the index in terms of like these SQL queries. So for some use cases, you would just want to incrementally add the new documents in. For our use case, every time we have a new version, because often there are new kind of documentation updates or things, we just had a big rewrite of a lot of our documentation. We just want to replace the index completely. That's really going to depend on your use case. But whether you're just inserting in directly to this embeddings table, or you're updating them with new values, that's just going to be the precise like update queries that you write there that determines that.
Cool.
So let's go to the next slide. I'm going to just kind of take a step back at the end. So obviously there are a lot of different kind of extra things that one could add into into this pipeline to improve it. We could add more evaluations and update these with kind of common failure cases. We could add better observability and instrumentation around the LLM calls, and I would definitely ask you to keep your eyes peeled for some new integrations coming out within the kind of LLM observability space soon. We can do a whole bunch of things around improving the retrieval. We can fine-tune the embeddings as a good example of that, and we'll be updating our guide, in fact, soon to showcase that, how you can kind of improve the retrieval by fine-tuning on your custom data. And then, of course, like you can even fine-tune the LLM. Let's say instead of kind of a chat bot, we wanted to output structured text or output the results in a JSON format or something. Then there might be a bunch of use cases where you would want to fine-tune the LLM, or or maybe you just don't want to be spending your money on OpenAI, or you have privacy concerns. So what I wanted to do, we've been talking about all of this in without so much reference to ZenML, but what I wanted to do is just take you through a bunch of ways where ZenML has been active in this process so far. Actually, it's kind of been involved in lots of the pieces of the code that I was showing you before, but I just wanted to make that explicit now, so we can go to the next slide. So the first of those is kind of data versioning. ZenML has data versioning as a first-class citizen. So if you want to kind of rewind, go back in time and see what your data was at a certain point, or check out the embeddings at a certain point, all of this is stored in your artifact store. And you can see with these examples, where the data versioning would be relevant and useful to you. Next slide, please. We also have kind of caching as kind of a key part of how our pipelines run. So if a particular step has run before, it will use the cached version unless you specify that you want it to not use the cache. And this is super useful during the development process because, as you can imagine, crawling the entire ZenML documentation recursively, this takes a bit of time. Generating the embeddings, all of this takes time. And when you're developing, you just want to be kind of working on the final bit, and then the earlier steps that you've already done, you don't want to have to rerun those, especially if they take a long time. So this is something which just works out of the box with ZenML. Then we have kind of the ability to connect all of the pieces of this very specific RAG workflow to other parts which you would expand later on. So when you go off and fine-tune the embeddings, this is kind of a separate project, and it has its own data set, has its own pipelines, but then you can hook this back into your RAG pipeline pretty easily with just kind of native things that come with ZenML. We also have this concept of the model control plane, which I didn't really talk about so far in the discussion. This is a way to bring the data and the models together in a kind of a holistic way. You can think of it a little bit like namespacing all of these things together. But this particularly in terms of a RAG pipeline where you have lots of different components and pieces, and you want to bring all of these together somehow, and to compare things and bring the artifacts from multiple disparate places. That's pretty useful. Reproducibility, cross-team sharing is another pretty important one. If lots of people are working on it, you have all of your artifacts and data in this cloud artifact store in Azure for this particular what I showed you this evening. And then if your teammates want to check out that work and then run pieces of the pipeline themselves, they have access to the same artifacts. They probably don't even need to rerun pieces of the pipeline because it's all cached already. So that's useful among teams. And then, just overall reproducibility is a key thing for a lot of the reasons that I was just talking about. That it's really easy to step back into previous experiments or to compare things between them. Plus, you have all of the different tools that ZenML integrates with. So that's kind of my fast overview of how you can work with RAG pipelines. And I realize that some questions have been coming in. So maybe you can raise them.
I think like the first one, how do we completely automate the generation evaluation? I think you already touched on maybe quickly, because when you start to put these things into a pipeline and start get adding observability early in the process, like you did, I suppose the reason you put things in a pipeline is you want to automate. So you can schedule this pipeline with ZenML. You could run it on Google, Microsoft, Lambda Labs, wherever, and you can
Connect up
automatically,
triggers. Yeah.
triggers. So there's like I feel like that's one question that I wanted to also touch on is MLOps and LLM ops. This is the part which is common, right? You always have data, you always have models, you always want to move things around and add observability. So all of those things that ZenML already brings as an MLOps tool can be applied to these topics, because magically the pipelines don't go away. You still need to move data around. You need to track these metadata. So I feel like that's where the missing gap is for often for some people. But we do have a few more questions. I just, because we're out of time, I just want to say one thing. So like, we will take your questions just as a call to action today. If you're new to ZenML, I hope this inspired you to check it out. This is only part one of the webinar. In the next part, we're going to be fine-tuning embeddings, and we're going to be fine-tuning a large language model. So to bring all of this thing together. So please, in order to keep in touch, I think the best way is to join our Slack. I already dropped the link for that. But you can also sign up for our newsletter. So I'm just dropping the link there. So every time we have a newsletter, I mean, you're going to get an email anyway, because you're part of this one. You can also give us a star on GitHub. We're open source completely. You can use everything that you saw today for free, self-hosted, and even locally. And we have a QR code here, which points to a form, which is going to be a special exclusive offer that we're doing in all of these webinars, where our team is on the lookout for production use cases for RAG, and we want to help. So if you scan the QR code right now on the screen, you will be led to a form. In this form, you can give us your name, your email, and describe your use case that you're working on at work, and we will come and help to implement this in production for you with our expertise. And we will select a few that want to work with us, and maybe we can even publish some material about it so that everybody of you can learn. We're all still learning this very early world of LLM ops, and we're building these standards together. So we are on the lookout for practitioners. Yeah, I just wanted to say that briefly. And now we can go to the questions. And if you have another appointment, then we also wish you a great evening. But I think we can slowly take over these questions. So I'm just going to scroll up, Alex. Maybe we can try to answer them together. There was one from Utsukhta. Sorry if I pronounced that wrong. How do we handle the scanned documents in a RAG pipeline? They implemented a RAG and they want to, it works fine for the PDF. I suppose they were using some Llama index stuff, but it cannot process the scanned documents properly.
So, I mean, yeah, for that, you're going to have a separate kind of data ingestion pipeline, which is just running OCR over the documents. And depending on what the documents are, you're going to need to extract the text. Potentially, you're extracting the images as well. We've got these great multimodal models, which are coming out into the world now. And potentially that's something you want to do. There are some pretty good, depending on the language of the documents, the OCR engine will be better or worse. But yeah, you just have a separate pipeline which is dealing with that data ingestion. Then that's kind of the.
I feel, Alex, correct me if I'm wrong, but I feel like that's where LangChain, Haystack, Llama Index are really handy as well, right? Like, this part is to read the data sources. I feel like they've implemented some really common data loading mechanisms. And the more RAG I see in production, that's the part where people are using LangChain and Llama Index and all those things.
Yeah, but just to demystify things, I would encourage, like, if you do find like a really useful like data loader from LangChain or something, I would encourage you to just go and check in the source code, and you'll probably be surprised at like how simple the thing is that's going on. You can often just take a look at how they implement it and then just implement it yourself. That often is a way to like future-proof your project, because LangChain changes pretty fast. And these libraries as well. So that's just a word of caution there.
Yeah, makes sense. We have one from Marcelo. How would you build a pipeline on microservices?
I'm not quite sure what that means. Maybe you have
I
an
think what
answer
they
for
mean
that,
is
Hamza?
so I suppose the background of the question is from a DevOps perspective, where we're building services that are long running. So
Mhm.
in machine learning, we don't tend to think about it in microservices. A pipeline is in a way a serverless job that runs. So in ZenML, for example, you can run a pipeline locally, and then you can switch a stack to, let's say you want to run it on SageMaker or you want to run it on Azure on a VM. You just switch the stack and you press play. The same pipeline builds a Docker image, pushes it to your Docker registry, triggers a job on whatever Lambda, and then orchestrates the job. That's all handled by ZenML. And when it's done, it spins back down. So um, there's no notion of microservices per se. There's no like aspect of a long running microservice with its own database packed. We have a centralized NML server, which could be a microservice, but generally that's a sort of a slightly different paradigm.
The inference
Um,
part might well be a kind of a microservice, which is just a container running somewhere. That's
yeah,
a separate thing, maybe.
exactly. I mean, the inference part could be different, like a fast API app. Saeed has a great question on instrumentation. So, any thoughts
Mhm.
on instrumentation for recording latency metrics? It's one of my favorite
Yeah,
topics.
I mean, for the actual LLM queries, there's a whole bunch of like really great LLM specific observability tools which do exist, and as I mentioned, we're going to be integrating with some of them. So this ranges from like Langsmith, which is the instrument observability cousin of LangChain. There's weights and biases. They have their own LLM tooling, Brain Trust, one which I really like. There's Inspect, a new open source observability. There's a whole bunch of different tools which you
I want
basically
to
wrap your OpenAI client, and then it captures all of these things.
plug Langfuse. So
Mhm.
our friends here from Langfuse, also open source, getting popular.
Mhm.
They're pretty good as well for instrumentation. Then the next question is OpenAI Vision, Amazon Text Extract, Azure Document Intelligence, OpenAI Omni. There's many places where you can work with image PDFs, and there's some open source things like Lava. Okay, so that was more of a comment on, I guess, the PDF question.
Yeah.
Um, any interesting data sets that you would recommend to explore? I would recommend the ZenML one that we just showed you, that Alex generated
Yes.
from his local Mixtral.
That's on the Hugging Face hub. Hamza, I guess you've pasted the link,
Yes.
or you can paste the link. But that just also, while you're there looking at the ZenML one, just look on the Hugging Face hub, and you'll find tens, if not hundreds of thousands of public data sets. And you can browse by use case as well. So you can say like data sets which are good for RAG projects, and there are a whole bunch of interesting ones.
Mhm.
But yeah, the ZenML one is public.
Cool. Jon Metz had a comment about LangChain. It helps you start soon, but it fills the roadblocks appearing to either lack of abstraction or over abstractions. So, there was a big debate on LinkedIn and Twitter about LangChain. It feels like they're getting bashed so often. I feel very bad for the team. Personally, at LangChain, at the end, it's open source, it's free to use. Um, things change, and it's hard to build abstractions. Maybe it was overly abstracted at the very start, but I don't think yeah, I mean, it's not helpful to always criticize, but I think the team, like Harrison Chase, is working hard on it, and they have great investors as well. Hopefully they can push the standardization of the LLM ops, specifically the data loading part and this abstraction over the vector stores part, which I feel like there needs to be some standardization there. uh, they can push that through.
And it's easy to forget, they did really push a lot of this wave as well of these
Yeah,
kind of
100%.
chatbot apps and so on. Like LangChain was really pioneering that.
Yeah. Any thoughts on how do you pronounce this? DSPY?
DSPY, DSPy. Um, Maybe you can go back to the slide with Hamel's tweet.
Yeah, I think
Um,
Hamel had a great take on this.
yeah. So DSPY is a prompt optimizer, and as Hamel wrote, prompt optimizer is a for loop to find the best examples. That really is what's going on. They have a whole bunch of different words and abstractions to talk about this, but what they're doing under their hood is they take your prompts and then they're changing words, they're changing things here and there, in order to get the best to get the best prompt. You know, obviously that there are some nice results which come out of DSPY. When I've looked at it, I found it a little bit complex, and there's really a lot of kind of going on underneath. A lot of it is abstracted away. I'm personally not sure if it's like the future of everything, but certainly like the idea behind it is interesting, I think, and promising.
Yeah, I mean, I think so. Again, I mean, people criticize, for example, LangChain for over abstraction, but DSPY is like a whole bunch of abstraction over thousands of LLM calls, right? But people seem to like it, and I can see its uses.
Yes, that's another thing. It's super expensive.
Yeah. So how can we manage to include the chat history as context for the current session? I think that's a relatively straightforward thing, right? With the OpenAI chat client.
Yes. So that will depend on the implementation. Also, note that the things that we were talking about here were basically single question and answers. So if you were dealing with like an actual chat history with conversation, you can be super naive and you can just like shove it into the prompt, or you can split it up in the code and say, the different user and machine responses. That's pretty easy to implement.
Yeah, the OpenAI client seems to be the standard, right, Alex? Like now everybody uses it, even if they're not OpenAI. So everybody uses the same interfaces.
Yes, although if you dive into our code database, you'll see that we're using Light LLM, which actually is kind of an abstraction around that, which allows you to switch out local versus OpenAI versus Anthropic. There are some differences, certainly with Ollama, and that kind of future-proofs your code a little bit. If you want to switch out your model, it's just changing one word instead of really changing a lot of things. So I recommend Light LLM.
Cool. Awesome. I can see from the time that it's way over. So really enjoyed this. Alex, thank you so much for your time and for staying up so late with me. I think it's just the start. As we said, this is just part one. There will be a part two with fine-tuning LLMs and fine-tuning embeddings. Personally, I love that part as well. And we've been doing a lot of experiments with that internally. Hopefully share it with everybody of you. Thank you so much for everybody joining all over the world, Pakistan, Morocco, America, staying up late or skipping your lunch break for this. A recording will be sent over. Please share it with your friends, share ZenML with your friends, and all the tools we mentioned today. And yeah, with that, I bid everybody a good day. Thank you, Alex.
Bye, everyone. See you.